All right, so we finished up with our straight angle and 90-degree angle and solving a two-step equation. Let's go ahead and turn the page and look at using our triangle and quadrilaterals. So let's do, here is an example for, if y'all can see it, our triangle. Say we have triangle that looks like this, and it is not drawn to scale. I'm not measuring this out, so it's not going to be perfect. Okay, so we have a triangle like this, and it's saying that we have this angle that's an x, this angle that's an x, and then this one is 70 degrees. Obviously, it's not up to scale, but we need to solve for x. We need to figure out what these two angles are. Now, since they are identified as the same type of angle using just one variable here, that means they are possibly the same number. Possibly, okay? But we want to be able to get to the math. So remember, a triangle's angle equals 180 degrees. So all three of these need to equal to 180 degrees. So if I have x, one of the x's, plus another x, plus the 70, this all should equal 180 degrees. Well, x plus x means I have 2x plus the 70 to equal 180 degrees. And now I can solve for x. I'm trying to get x by itself. So we want to subtract 70 from both sides of the equation to balance it. Zero pair, 70 positives and 70 negatives means 0. Okay, I haven't done anything with the 2x yet. 180 minus 70 is 110. And then we're dividing, because this is multiplication, 2x. We're dividing by 2. Okay, this gives us 1x equals 2 into 11, 5 times with 1 remaining. 2 into 10, 5 times. So x equals 55. 1x equals 55. That means that this x equals 55 degrees and this x equals 55 degrees. They are both the same x's. All right, you can plug in and solve. So that means into this original one, I would have 55 plus 55 plus 70 should give me 180 degrees. Well, 5 plus 5 plus 0 is 0. Carry the 1. 5 and 5 is 10, plus 7 is 17, plus the 1 is 18. So 180 equals 180. Check. Okay? That's what we're looking to do. One more example with triangles, because it doesn't have to be a perfect right angle or anything like that. Let's say that this is 3x. This angle is 80 degrees. And this angle x is an x. What x degrees, that's what I mean to say. All right, so we want to find the value of x. So remember, triangles equal 180 degrees. So adding all three angles together, we should get 180 degrees. So we take x plus the 3x plus 80, and I should get 180 degrees. Well, x plus 3x. Here I'm combining like terms. Here I combined like terms too. So let me go ahead and write that. Combine like terms. And combining like terms mean that you didn't see it, sorry. Combine like terms. Combining like terms is they look the same. This is the variable, okay, which becomes a coefficient. These are constants. Okay, so in our second example, we look at it and we say that our coefficients is x, combining the like terms, x and 3x. So those two together, 3x plus x is 4x plus 80 equals 180 degrees. Well, I need to solve for x. So the first step is to do the subtraction of 80 on both sides. 0 pair here. Bring down your 4x. And 180 minus 80 is 100. Now 4 times x, because I'm trying to get x by itself, I divide by 4 on both sides. Okay, this gives me the 1x equals 4 goes into 100 25 times. Okay, from there, you can plug in 25 in for x. So this means, let's go ahead and plug in with a different color. We're going to plug in with orange. This means that I would have 25 plus 3 times 25 plus the 80 equals 180 degrees. Okay? 3 times 25, 3/4 is 75 cents, right? So we would end up with 25 plus 75 plus 80 equals 180. Okay? 25 plus 75 gives me my $1 whole. And 100 plus 80 is my 180. Check. Cool. All right. That's going to conclude it for this lesson. Please make sure that we understand that we are looking at all different types of angles and degrees. So we have our straight line, which is 180 degrees. Okay. Our 90 degrees or right angles, which is 90 degrees. Then we're mostly looking at some triangles, that the triangles equal 180 degrees. And and you can combine like terms in order to solve for the variable. You know, I just realized I did not get in a rectangle or quadrilateral. So let's go ahead and squeeze one in here at the bottom. And let's get one done. So what if we have our rectangle, or not rectangle, but our quadrilateral. We have this as, remember, what does a quadrilateral equal? 360 degrees. Okay, so all 4 angles should equal 360 degrees. Okay, so what if we have that this is 121 degrees. We have 32 degrees. 32. Let me see if I can get that closer so you can see. 32 degrees. And then we put, I don't know, let's say that this one's 57 degrees and A. Okay, so all 4 of these angles added together should equal 360 degrees. So we have A plus 121 plus 32 plus 57 equals 360. Okay, the best thing to do is to add up all 3 of your numbers that you already have. I'm going to come over here off to the side. I'm going to do that. 121, 32, 57, 7, 8, 9, 10, 8, 9, 10, 11, 210, plus the A, because remember it's still there, 360. To solve for A, this has now become basically the one-step equation. So we subtract 210 from both sides. That gives us A by itself. When we subtract, we get 150 degrees. So this A equals 150 degrees. Okay, so now that is going to conclude it for our quadrilaterals. triangles, supplementary angles, and complementary angles. Please remember you have 180 degrees in there for supplementary and triangles. You also have the right triangle or right angles, for complementary angles. And then your quadrilaterals are going to be your 360 degrees.